Hi, we are Group G, and today we are going to talk about Launceston Airport site remediation.
So our topic is Launceston Airport site remediation, which is recently found to be contaminated by a man-made chemical that is called PFAS. PFAS, also known as per and polyfluoroalkyl substances, is a man-made chemical compound which was used partially in different work of firefighting. It is actually mainly used as a firefighting foam because of its high heat resistance. But recently, it has been found that it is actually contaminating few parts of the Launceston airport, and the contamination have gone to a level that it can actually harm the people that is living nearby, as the soil has been contaminated. Soil has been contaminated of the airport, and now it is seeping through groundwater, the contamination, and also with runoff, it is contaminating the local waterways as well. And it has been found that the exposure to this chemical can cause cancer and also have different other high risk for human health as well as the ecosystem that is surrounded by the airport.
Topography and geology. Launceston Airport consists of 180 hectares located in the Thames Valley, a valley known for its sandy nature and poor water quality. Launceston Airport has been established on a gentle undulating landscape, overlying relatively solid foundation of basalt. The airport is surrounded by various waterways, endangered by the easily draining soils and the falling landscape on the east boundary of the airport. Former land use. Prior to Launceston Airport, the land was used as the Royal Australian Air Force Base, aircraft rescue and firefighting station, and fire training ground, before the land was purchased by the Australian Pacific Airports in 1998. The airport is accessible to commercial aircraft, air freight, and private operators and their respective passengers, visitors, and employees. Surrounding land. The airport is surrounded by agricultural farming land, residential land, and industrial estates. The site has two underground monitoring wells. They're used at 2 metres and 12 metres depths. They record low seepage rates annually, with relatively high salinities, also considered ranging from 500 milligrams per litre to 1500 milligrams per litre. The possibility of groundwater contamination in the vicinity of Launceston Airport and surrounding areas is moderate, with the nearest licensed bore located 2.4 kilometres northwest of the airport. Risk assessment. PFAS is a large group of compounds of fully fluorinated hydrophobic alkaline chains. Areas of potential concern include aircraft rescue and firefighting station and vehicle maintenance areas, hangar areas from the Royal Australian Air Force, soil stockpiles, former waste detention ponds, and mobile fuel farm. Pathways of contaminants: direct spillage, contaminant leaching, stormwater runoff, air dispersion, dermal contact, and inhalation. Effects include health of humans and animals, the health of surrounding ecosystems, and the health of waterways. Risk matrix. The risk matrix defines the impact and likelihood of detrimental circumstances involved with PFAS contamination at Launceston Airport. The possible harm that PFAS contamination poses is of an unacceptable limit, with the risk of exposure of contamination greater than 1 in 1 million, as confirmed by the calculations. It's likely that contamination and harm will occur to human health and the surrounding ecosystems. The star marked on the matrix represents the level of risk evident from the hazard of PFAS contamination at Launceston Airport. Site remediation action is required.
For the problem of per or polyfluoroalkyl substance contaminated media, there are several approaches that can be employed, such as excavation and offsite disposal, or contaminant based approaches, or the treatment based methods. As we know, the excavation and removal of soil and sediments which contain PFAS and disposing to a landfill for further treatment activities is the most common and direct approach to solve the trouble. However, the trouble of PFAS not only targets to the surface soil with the properties expanding, it can easily dissolve into groundwater and aquifer. Therefore, another approach could be defined as pump and treat method, which is basically contained in the treatment-based methods. As we can see, there are three main treatment-based methods. They are pump and treat method, adsorption method, or bioremediation. The pump and treat methods uses the excavation. The removal of various carbon sorbent particles from the water, and then before giving it out for a proper drinking process. That is a pump and treat method. Water is pumped from the groundwater, the carbon component is removed and then treated and given out for drinking purposes. The next one is adsorption treatment. The absorption treatment strategy by using activated carbon both in powdered and granular form to remove the PFOA and PFOS from water body has been enhanced. From both laboratory and industry scale, the effect of using activated carbon adsorbents to remove the PFAS provides significant impacts. It has two types of resins, which is the cationic and the anionic. The cationic resins are used for positive charge contaminant removal, and the anionic is used for the negative charge removal. In addition, another one is the bioremediation approach. Bioremediation approach is the process by which biological microorganisms are used to remove the PFAS removal. The degradation of PFAS by microorganisms in the aerobic environment boosts the production process of fluorinated from the microbes transformation in corresponding ancestors. The various bacteria found are used and that they are treated. They are used for the removal of PFAS from various substances or various soil textures in the land. So these are the three which is being discussed. The rest, the chemical and thermal treatment, are the other ones.
Chemical and thermal treatment are also strategies to disrupt the structure of PFAS through the redox reactions. For example, from a laboratory scale, the degrade of the PFAS is realized by the oxidation factor of the mixture anoxic oxides, catalytics, and electrocatalytics. The mechanism of the process is supported by the presence of the high reduction potential of metallic compounds under high pressure and high thermal temperature. Another chemical treatment of the persulfate oxidation factors, which support with the water at high temperature, provides significant impacts to the removal of PFOA. The removal efficiency of the PFOS may achieve at more than 97.5% with the presence of the persulfate oxidation elements as a terminal outcome of the groundwater and soil contamination management. The thermal treatment involves temperature at around 1000 Celsius degree to degrade the contaminated soil in the initial stage. However, to completely remove the PFAS in both in situ and ex situ treatment method, higher temperature is required, about 1600 to 2000 Celsius degrees, which also known as the incineration process. After the heating system, the vapor of the PFAS is released into the natural atmosphere through the industrial air filters. The thermal treatment methods had a significant benefit on the removal efficiency of the PFAS, as the thermal destruction of the PFAS is recorded in the range of 71% to 99% removal rate.
In this section, I will talk about the costs associated with site remediation. The costs associated with site remediation includes the site investigation costs and soil remediation practice costs. The site investigation, also known as environmental site assessments, including two phases. The first phase is preliminary site investigation. It involves a desktop study of the potential contamination on the site based on historical activities. The average cost for phase 1 is typically from $1,000 to $2,500 if phase 1 assessment reveal evidence of contaminating activities. A phase 2 environmental site assessment is required. Phase 2 is referred as subsurface investigation, where samples of soil, groundwater, gas are taken and tested. Phase 2 assessment normally costs about $5,000. The cost estimation has been done for the in-situ thermal disruptions. There are a few assumptions has been made. The contaminated area is assumed to be 2,000 meters square. Assuming the depth of the contaminated land is up to 12 meters, the deepest depth where the groundwater present. Assuming the soil bulk density is 1.7 grams per centimeter cubed, which is equal to 1.7 tons per meter cubed. Volume of contaminated soil is calculated to be 24,000 meter cubed, which given 40,800 tons of soil need to be treated. Thermal treatment capacity of contaminated soil can be up to 20,000 tons per annum. Therefore, it is estimated that the time to treat the contaminated site completely is approximately 2 years, and its treatment cost is about $8,364,000. The total cost for site investigations is $7,500 plus the site remediation cost. It's giving us an overall of $8.4 million spent for the whole site treatment. In the next session, my teammates will talk about the actual site remediations and its effectiveness.
The actual site remediation at the Launceston Airport. We'll be talking about that. So the north side, the east side and the south side of the site has agricultural land. On the east side, there are various creeks and tributaries. On the west side, there's residential properties and industrial sites like warehouses and offices. So surrounding the airport, there are possible ways of exposure pathways. So we're talking about possible exposure pathways. There are different ways how the contaminant can affect the soil, groundwater, surface water, humans, and other things. So the pathway for the possible exposure is direct spillage, contaminant leaching, and stormwater runoff, dermal contact, dust inhalation, agricultural crops. The hierarchy for PFAS management according to the National Environmental Management Plan are as follows. The first one is you either do isolation, treatment, or destruction. Second one is on-site encapsulation in an engineered structure with chemical or without chemical. Third one is removal off-site of the contaminant to a separate landfill. The remediation technique that has been carried out so far at Launceston Airport is the excavation of 100 tons of PFAS infected soil, where it has been sent to a local facility and it has been destructed at really high temperature. And then the second one is control of soil stockpile at the site. Third one is the application of a trench to remove the hazardous groundwater. And finally, there has been a covering of the former fire training site to inhibit the toxicity of the rainfall.
So it has been found that the PFAS and polyfluoroalkyl substances can cause a different health risk towards the people that are living nearby the airport, and it is we calculated and we found that it is more than 1 in 1 million, which is still at an unacceptable rate, and different procedures can be taken up and already been taken to contaminate to decontaminate the soil, such as the one of a few of the approaches can be the excavation of that soil and dumping it off to different place, and then use that soil with different treatment based methods such as chemical treatment or thermal treatment to destroy the substances that is contaminating the soil. And we cannot say enough that the total elimination of this contamination is needed, because this substance is still posing a high risk towards the human life. Those the people that are living near the airport, as well as the surrounding ecosystem. So the amount that is there right now in existing is actually can cause a huge health risk towards those people. So the local authorities, local government, as well as the airport authorities should work together to remediate this problem as soon as possible. So thank you guys for listening to us. Hope you guys enjoyed the presentation.